This is the video notes for section 3.2, slides 8 and 9. So in section 3.2, we're talking about the derivative of the exponential function. So the derivative with respect to x of e to the x. So we haven't discussed anything related to this yet. So we're actually going to have to consider this from the perspective of the limit definition of a derivative. So our function here is going to be e to the x. And so in order to find the derivative, we are going to find the limit as h approaches 0 of f of x plus h. So that would be e to the x plus h minus f of x. So e to the x all over h. All right, so now this is the limit that I want to evaluate. All right, so first of all, e to the x plus h. So how do I think about e to the x plus h? Well, if I have e to the x plus h, we could rewrite that as e to the x times e to the h. All right, so just a reminder, if I go over here on the side, if I have x squared times x cubed, that is equal to x to the fifth. Why? Because I add the 2 and the 3 together. So if I have e to the x plus h, I can always go backwards and write e to the x times e to the h. Then I have minus e to the x and all divided by h. All right, so now we notice there's an e to the x in both the numerator, in both terms in the numerator, so we're actually going to factor that out. So the limit as h approaches 0 of e to the x times e to the h minus 1 all over h. All right, so now the next thing, okay, the limit as h approaches 0. Well, think about this. H is approaching 0, but x is not changing as h changes. So e to the x is actually independent of the limit as h approaches 0. So we could actually bring e to the x out and then multiply it by the limit as h approaches 0 of e to the h minus 1 over h. Now, in order to solve this limit, we're actually going to need to go to a graph or something. So I'm going to go to the graph, and I'm going to graph e to the x minus 1 over x. All right, so on my calculator, all right, I go to y equals, and I'm going to graph e to the x minus 1, all of that divided by x. All right, so now when I graph that, I get this. Okay, now I'm going to change my window a little. So I'm going to go from like -2 to 2, and then -2 to 2. So we are looking for the limit as this function approaches 0. So if we see that, its y value here is actually 1. So if I look at e to the h minus 1 over h, the value of the limit is the y value of that graph, and so it's actually 1. So that means e to the x times 1, which means what? That the derivative with respect to x of e to the x is e to the x. So very simple. The derivative with respect to x of e to the x is e to the x. All right, so what does that mean about the derivative with respect to x of e to the u then? Well, very simple. That means it's e to the u, and then apply the chain rule times du dx. All right, so that is our rule. This is the rule that we want to memorize for the memorization quiz. All right, and then moving on to slide number 9. So applying some of these basic rules. All right, so number 1, y equals 7 times e to the 2x plus 3 times e to the 4x. All right, so 7 e to the 2x. All right, so dy dx. All right, we're going to bring the 7 down and multiply by the derivative of e to the 2x. All right, so apply the rule. The derivative of e to the 2x is going to be e to the 2x times the derivative of 2x, which is 2, plus 3 times the derivative of e to the 4x, which is e to the 4x times the derivative of 4x, which is 4. So we would clean it up a little and rewrite it as like 14e to the 2x plus 12e to the 4x. All right, so now the next one, number 2, y equals e to the sine x. All right, so dy dx, once again, I'm going to take the derivative of e to the sine x. So e to the sine x times the derivative of sine x, which is cosine x. So very simply, you might rewrite it as like cosine x times e to the sine x, but really those aren't any different. All right. And then the last one, okay, we still have to be able to apply the chain rule and all of our old rules. So dy dx. All right, derivative of tangent of e to the 5 minus 6x. All right, so now remember, tangent is the outermost function, so we take the derivative of tangent, which is secant squared of, remember the inside stays the same, e to the 5 minus 6x times the derivative of e to the 5 minus 6x. So what is that? Well, the derivative of that is e to the 5 minus 6x times the derivative of 5 minus 6x. So the derivative of 5 is 0 times the derivative of minus 6x, so that would be minus 6. And remember, that is being multiplied by this stuff, not subtracted. So maybe you would rewrite it as negative 6 e to the 5 minus 6x, and then times the secant squared of e to the 5 minus 6x. So that is slide number 9.